So, good evening. I'm Calvin Joseph, and today I'll conduct the Week 12 problem solving and doubt clearing session for the NPTEL course Digital Electronic Circuits. So, today is the last session for this course, and finally, you will have the NPTEL exam. So, I'll share my screen. Just hold on, I'll open the writing pad. Okay. So, today is the week 12. So, congratulations, you have been able to come to the last week of this course, that you have persevered and studied this very important subject of digital electronics, which will be very useful for you. So, this week we are talking about memory. Okay, memory is like what we retain, like something which is stored, right? Stored information. So, memory is of mainly two types, which we all are very familiar when we buy a desktop PC or a laptop, or we buy phone. We say how much is the RAM, right? How much is the RAM? If the RAM determines how fast our applications will be able to load the program and be able to run the program and execute, we focus on the RAM and stuff, right? So one is RAM, that's what stands for uh, random access memory. There's also another type of memory called ROM, that is known as read-only memory. Okay, so these are the main types of memory. So, like for a human being, we say the brain is what stores various memory about what we study, what we learn, everything, and we have to kind of access the information from our brain to tell something. So, in the exam time, what happens is the stuff which we have stored in our brain, which we have done, we have studied, we have learned, we have tried to memorize, we have to access that from our brain. Okay, so that's why it's better before you go to the exam, you go with a still calm mind and you go revise the main important parts such that it is fresh in your memory. So somewhere, if I have not mistaken, somewhere I heard that at a time we are only using 10% of our brain. So that's why certain things will be stored underneath, which would have forgotten long back. But then later, when proper stimulation or proper something trigger comes, the thing which was stored in a memory, it comes up, it flashes back. Okay, so just a simple thing, analogy for you to remember, as you'll also soon have to give your exam and you'll have to remember various things about this digital electronic course. Okay, so we have two types of memory, random access memory and ROM, read-only memory. In RAM also, sir had taught about various, SRAM, that is static memory, which needs no refreshing. And there is something known as DRAM, which is dynamic and which needs refreshing. Okay, because the DRAM stores the information in the parasitic capacitance of the MOSFET. So because of the actual parasitics, it will slowly discharge, and if it discharges, it will lose that information. So to prevent such a thing occurring, we periodically charge it such that that information stored within it is present, it is available. And there are various other memory devices as well. So one thing you must understand is memory, you can either read information from it or write information to it. So let us say this is our RAM. Hmm? We'll say it is of 8 bits. It's a 8-bit RAM. So RAM can either store 1 bit, or it could either store 8 bits, or it could either store 16 bits. It could either be a bit-based arrangement or a word-based arrangement. Okay, let us say we are going with the word-based arrangement. So 8 bits means it should have 8 data lines. So it will have D7, D6, all the way to D0, right? This is known as the data line. Now, let us say it is 1K RAM. Okay, let us say it is 1K RAM. What it means, 1K stands actually here for 1024. That is basically 2 raised to 10. So 2 raised to 10 possible addresses are available. So that means it will have an address line which is going from A9 all the way to A0. So this is the address line, right? So it means there are 1024 locations where in each location we can store 8-bit data. Okay, so I'll try to. So if my A9 all the way to A0, all the address line bits are set to 0, means it will go to location 1. Okay, it will access the information in location 1. Okay, and then if it goes to 0, 0, all are 0, and this is 1, so it will access the information in location 2. Okay, and in each location you have 8 bits of information. Okay, so that's why it is able to access that information based on your address line bits. So the address line is setting it up that here I want this information which is stored in this address, right? You would have learned of pointers and various other things. You would have learned microprocessors, everything. They have an address bus, they have a data bus. Okay, so similar thing you can just correlate to help you understand. Okay, so this is for RAM. In the case of ROM, you only can read. Okay, so you only can access the information. And here also you will have your address bus A9 to A0, D9 to D0. But in this part, you can only read. Okay, you can only read data. But over here, data is bidirectional. You can read as well as you can write. Okay, writing data means at this location, I am going to write this information. That I'm going to store this information over here. Read is I go to that location, and whatever is stored in that location, I will take that data and I will access it. Okay, so that is read and write. Okay, those are kind of like separate instructions, everything. So this is a part of read and write. So there is also a way of read memory cycle. Okay, when you want to read information, it has a certain timing diagram. You will some enable something, and there will be some delay. There will be some sort of delay will be there, and then at this point some your data will be available. This is just a rough diagram. It is not actually what happens. It's just giving an idea. That is, you say I want to read the data from the bus, from that from the address, from that memory location, but instantaneously you will not get that information. You'll have to wait for some time. And after you wait for some time, the data is available. The data is in a format in which you can read it. It is not corrupted. It is as it is. You can read that data and you can use that data. So you must leave that necessary sufficient gap and time while doing your work. Okay, so this is the read memory cycle. Similarly, there's a write memory cycle as well. Okay. So you must read the timing diagram and carefully understand when you are using any particular memory IC. You'll have to know how much time delay you have to give before you enable a signal, and then you send the data or you read the data, you send the address information, and so on and so forth. Okay. So let us start with the assignment question. It will give us better idea. Hmm. So let us start with question 1. Sorry. So what do you see here? It is given there's a 64K cross 16 memory. So 64K corresponds to the address bus or the address line, and this corresponds to the data line. So 16 means what? It is 16 bits are there. Okay, and you have 64K. So that corresponds to 64 in 1K is what? Into 1K. And in terms of memory, it is 2 raised to 10. Okay, 64 into 2 raised to 10. Now, what is 64 in terms of 2 raised to? Can you tell me? 2 raised to what is 64? Is it 2 raised to 5, 2 raised to 6, 2 raised to 7? What 2 raised to 8, which corresponds to 64? Hmm? Raj, ready? Anyone? I'm asking what is log of 2, log of 64 to the base 2? Yes. So Ravi is saying 6. Okay, good. So, okay, 2 raised to 6, good. Just hold on. Hmm. Good. So both of you have got 6. So that is, it is 2 raised to 6 into 2 raised to 10. So by, the laws of indices, it is 2 raised to 6 plus 10. So it is 2 raised to 16. So that corresponds to 16 will be your address line. So basically this is the RAM. Okay. This is the RAM. It has this A15 onwards to A0. This is the address line. And this is your D15, D14 onwards to D0. Okay, this is your data line. Hmm. Okay, Raj, you have a doubt regarding exam? You can tell. You can even send a message. Okay, will the questions in exam, will they come from the assignments? It necessarily won't be the same, but it should be quite similar. Like to what I've heard that um, there is some component of marks is there for, it's like a very simple question, like some memory based question. That is something which has been taught in class. You have to, like we are teaching about memory, right? So there are certain questions that is some information which has been taught in class, which is there already available. Based on that information, you have, based on your memory, you have to have your recalling power. Certain questions are there. There's certain weightage for it. Then there is a certain weightage for questions that are based on the assignment. They're similar to the assignment questions. So if you have gone through the assignment questions, you should be able to solve those type of questions. And there are certain questions which are difficult, like which are, the tricky questions for which you have to go through it and understand it. Okay. So, Radi, you also have doubts regarding exam. And Raj, can you tell where can I get the recorded lectures? Recorded lectures of these NPTEL sessions or uh, the session doubt clearing sessions which I'm conducting? If for the doubt clearing sessions which I am conducting, I can share the link of the YouTube channel where I'm uh, putting the uploading the videos. You can refer to that. Okay. So I've sent the link where the YouTube channel link as well as a drive link where I upload the notes for the sessions. So you can check it out as well if you have any doubts, any queries. Then can you tell about the paper pattern? Um, Paper pattern, that's what I said. Like some part of the questions will be from memory, some part of questions would be from uh, kind of like assignment based questions, and certain few questions are tricky where it may not necessarily have been from your assignment, it may not necessarily have been from your class. It is some little bit, you have higher order thinking questions, bit of that. And syllabus is what is there in the NPTEL course, right? You have 60 lectures and you will be able to access it from the NPTEL course. What is the syllabus and everything? Okay. Passing marks, those all information I don't know. I'm not sure. I have never given an NPTEL exam, so I don't exactly know what is the passing marks and what is the criteria. Hmm. Okay. Okay. No, I don't have last year's paper, unfortunately. But I don't think you guys should worry so much about the paper and everything. Because if you have been solving the assignments consistently, faithfully, I don't think it will be that much of an issue. You'll just have to revise it a bit. Yeah. I don't think whether you can get, I don't know about getting the last year's question paper. I don't know whether there's any source. I'm not sure. No, to my knowledge, there's no negative marking. There's no negative marking in NPTEL. Could actually see for they will have certain information regarding some instructions will be there. You better read those instructions before giving the exam. But as far as I remember, there is no negative marking. Hmm. Yeah, so we'll proceed to the next question. Okay. Yeah, if you have to leave, you can leave. Those of you who want to stay can stay. But all the best for your exam. Okay. So again, you have memory chip 20K cross 8, right? So again, 8 is your word length, 8 is your word size, right? That corresponds to 8 bits, and you have 20K. So that is 20 into 1024. So what is 20 into 1024? Can you tell me? What is that value? Also, you will have to use the gate calculator, gate type of calculator in the exam. You cannot carry your own calculators. So you'll have to be familiar with the gate type of calculator and use it. So what I usually recommend is you try to learn how to do the calculations, preferably by hand. Less rely on the calculator, as well as when you're attempting the question paper, the exam, don't waste time in a difficult question. You first read through the question paper, see which are all the questions, everything. You go to a question, if it is simple, if you can solve it, solve it. If not, you leave it and you come back to it later. Hmm. So it would be good if you can go sequentially. That is, you do question one, then you do question two, you do question three. Suppose you do question one, question two, and question three, you got stuck, right? So what I prefer to do is you write each question, you write what is given and what you need to find. Okay, so the next time, like if you write, like let us say for this question, I will write, given what information I have, it is 20K cross 8, right? And to find what I need to find, the word storage and the word length, right? So suppose this information I have written, then next time I don't need to go and read the entire question. This is a small question, so it doesn't make that much of an important difference. But certain times you have a 5, 6 line question, right? So you can't each time go and read the question all over again and everything. Okay, so this is the certain tips which you need to follow when you're giving, these competitive exams, when MCQ based exams. All right, and there are certain questions which are numeric answer type. That is, you have to give a numeric value. You have to give like 8.5, 8.2. Accordingly, they will write how many decimal places they want you to give the answer in. Okay, so in those cases, be careful. You also note down what are the units required. That if the answer requires the value to be in millivolt, right? You might get the answer is 0.03 volt, and you might write the answer is 0.03, but the answer may actually want you to give the value in millivolt. So you have to know to convert it to 30 millivolt, right? So all these small things, you better be careful, pay attention closely, you watch it. What exactly they are asking and what answer you are giving them as well. Okay. Okay. So 20K into 20K is 20 into 1024. That uh, on simple calculation, you will get it to be 20480. So the correct answer is B. So that is, you have 20480 are the number of words that can be stored on this chip, and the word size is 8 bits. Okay. So let us go to question number 3. So setup time is the minimum time between placement of valid address and write disable. Statement 2 is access time is the time to be allowed between placement of stable address and availability of stable data. So which of these statements are true? Which of these statements are false? For this, I'd like to show you the what sir has taught. Hmm. Okay. I was telling them you have this memory read cycle. So what does this memory read cycle consist of? You have an address. This is the address bus where you will put the address line, address data, address information. So suppose this a valid address comes. Okay, when the valid address comes, since this chip select is active low, it has to go low, right? And you have also written that it is R. R is active high. So if you see this signal is high, that means you are going to do reading. You're not writing. So you're only doing reading. And this is the data which is available. Hmm. So you have the chip select has gone down. That means you're accessing this chip. And you have made sure that it is only doing the read operation. And at this point, where my mouse is, you have put a valid address. That is, you have told that I want to access the data. That is, let us say in address FF01H. Okay. Then from this point till the point where you get that data actually is available from the memory, that it takes some time to access and get that information. That is known as your access time. Okay. And this overall cycle is known as your read cycle. This is overall known as your read cycle. Similarly, for your memory write cycle, what you do over here, you have certain address, you put that valid address. So in each case, you must say that you must give the address information. First, you give the address information, and then you also select that chip. And since it is active low, the chip select has to go low. And since you are writing, specifically you are writing information, what you will do enable the write. So how do you enable write? By making it active low, by it going low. Okay. And then in your input data, you will add some valid data. Okay, you will add some valid data. And once you have added that valid data and it is been there for a certain duration of time, you have written that data, then you can again make your W bar high. Okay, so it's like disabling it. Hmm. So So over here, what they ask access time, setup time is the minimum time between placement of valid address and write disable. So if you see setup time is minimum time between placement of valid address and write enable, not write disable. So that is why statement one is false. Hmm. And statement two is access time is the time to be allowed between placement of stable address and availability of stable data. So this is for reading operation. So access time is the time to be allowed between placement of stable address and availability of stable data. So statement 2 is true. Okay. So that's why over here what you have statement 2 is true, but statement 1 is false. Hmm. For this, you must refer to memory and write cycle. Okay, refer to that. So we'll go to the next question. This is a bit of a difficult question. We'll come back to it later if we get time. Let's consider this question. Yeah, it's better to go for theory questions, but you should remember the theory that is also there. Hmm. Hmm. So now, this is a type of question regarding matrix based memory addressing. Okay. And now, let us see what they have given. Consider if row address is high, column address is high, and read write is low. If r bar slash w is low, what does r bar slash w equal to low mean? Does it mean you're doing reading or writing? Can you tell me? If r bar slash w is low, are we going to do reading or are we going to do writing? So r bar is low. So that means r is bar means it is enabled when it is low. So that means we are doing read operation. Okay. We are doing read operation. And data bar is equal to low. Data bar is equal to low. That means what is data? That means data is high. Data bar is equal to low. That means data is equal to high. So that means what will happen? Your D out will actually be high. Okay. So that means you're basically doing read information, read operation, and the information which you get is D out is equal to high. Okay. This is the answer. So it's a very simple question. See, there's a very big complicated circuit is there. That's meant to confuse you. It's very simple. You have, it is reading, and then your data bar is low. That means your data should be high. Okay, that's all there is to this question. Okay. Okay, so this is a complicated circuit of a type of memory cell. Okay, it's a type of memory cell. So this is the data line and this is the data bar line. So if data bar was 0, that means your data line should be 1. Okay, your data line should be 1. Then you have your R bar slash W. This is the MOSFET or FET, which controls whether you're reading or writing. Now, how do you control it? If your R bar slash W, if that is 1, that means what? W you're working on. So what will happen? It will be write operation will happen. That means you will be writing some information, you will be storing some information into this memory cell. But in case this was low, means you're focusing on reading, and in that case, read operation will occur. That is whatever and when read operation occurs, what do you want? You want the information which is stored in the data line to be accessed available over here, right? So they have first told that it is in this configuration. That is, it is in sorry. Did it come like this? It is, they have told that it is in this configuration. So we know that read operation is occurring. So it means the data information is not being changed. The data information can be changed only in write operation. But now we have configured it to be in read operation. So the data will not be changed. Only the data has to be read out. So they have told that data bar is low. That means data should be 1 and your D out will be equal to your data. So your D out will be 1. So 1 stands for high, right? 1 is high. So that means your D out is high. Okay, so that is all is there in this question. Okay, so I hope this has cleared this question for you. Hmm. Okay, so let's go to the next question. Okay, this is a little bit long question, but a very interesting question. It helps us to understand what actually is a ROM based circuit. Okay. So this is a decoder or ROM circuit. So what is a decoder? What is a decoder? It will have, let us say, a 2 to 4 decoder. It will have this data. It will have let us say control input, C1 and C0. Okay. It will have your D0, D1, D2, D3. Okay. So you have C1 and C0, and you have D0, D1, D2, and D3. So if it is 0, 0, means what? D0 should be active. So this will be 1, rest all will be 0. If this is 0, 1, means 1 has to be active. So this will be 1 and rest all will be 0. If this is 1, 0, that means D2 should be active and rest all are 0. And if this is 1, 1, these all are inactive and this is 1. So this is the job of a decoder. Okay, it's a job of a decoder. Now, suppose and so this is, if you talk in terms of min terms, this is 0, 1, 2, 3. Suppose you want min term of 1 and 2, then what you should do, to the output of a decoder, you connect it to an OR gate of this. And then you get this min term expression of summation m 1, 2. Okay, so basically this is a decoder. So in a ROM circuit, what do you have? You have a decoder, and it is followed by a set of OR gates, which are accordingly connected such that you get certain functions. Okay, you get certain functions. So let us look into it. So this is a very small example I'm giving you, and then we will look into the actual example which is pertaining to this question. So we have, what do we have? Uses 4 address lines. Okay, uses 4 address lines. Find the min-term expression at the output of the OR gates if the ROM is hardwired to store data 0010, 0110, 1010, and 1111 at certain address locations. Okay. So let us say, so we have a ROM based memory. ROM means you can only read. Okay, so ROM based memory. So you have certain address line and you have some data line. Okay, we will write it as A3, A2, A1, A0. And the data line or the data bits which will come are D3, D2, D1, D0. Okay. So since this is a 4-bit, so there are 16 possible combinations. So what do we have? We have 0000, 0001, 0010, 0011. Okay, then we have 0100, 0101, 0110, 0111. Then again you have 10, 1000, 1001, 1010, 1011, 1100, 1101, 1110, 1111. So basically, we are writing the truth table sort of. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now we have got this. Now what do we do? Let us see the question. What it says. It stores some data. It stores 0010 from all 0 to 0011. 0011. So what it does? It stores over here 0010. So this is 0010, 0010, 0010, 0010. So this is for the first four address locations. It is storing the same information. Next, so we have completed 0010. Now we have to go to 0110. It stores this value 0110 in the address locations. What address location from 4 to 7? Okay, so it stores 0110, 0110, 0110, 0110. From 4 to 7, it stores this particular bits word of information. Next, we will go for, it will then store 1010 from 8 to 11. Okay, so what is it storing? It is storing here 1010, 1010, 1010, 10110. Okay, very good. Now we will see for what part it will store 1111 at the address from 1100 to 1111. That is from 12 to 15. It stores here all ones, all ones, all ones, all ones are stored. Okay. So congratulations. So whatever has been written in the question, you have written that information over here in this truth table. So now what you have to find out, you have to find the function. Let us say, let us do for, let us start with D3. You have to find for which and all values D3 is high, because you're finding the min term expansion. So f of D3 is actually the summation of m of this, so on. So that is it is summation m from what? 8, 9, 10, 11, 12, 13, 14, 15. To my knowledge, rough sheets will be provided, but I'm not sure. You can, I don't exactly know. So I actually feel like I haven't actually given any NPTEL exam, so I'm in that way it's a bit of a handicap for me to help you guys. But I hope you can ask your seniors, you can ask people who have given the NPTEL exam previously. They will have a better idea. Because yeah, in this for such a for this particular type of subject, you really need lots of rough sheets and everything for doing solving the sums. Okay. So now let us see for f of D2. So where it is from 4 to 7 and from 12 to 15. So what is f of D2? Summation of m from 4, 5, 6, 7, 12 to 15. So 12, 13, 14, 15. Okay, well and good. Now D1, how do we write? It is always 1. So f of D1 is actually equal to 1. And what is f of d0? It is where it is 1. So f of d0 is summation of m 12, 13, 14, 15. Okay. So this is how you must solve this question. All right. So we'll go to the next question now. This is question number 5. Question 6. So we have to go to question 7. So these are certain questions. So you have to write true and false. So is the main memory of a computer system, should it be non-volatile or volatile? What do you say? So non-volatile memory is basically your ROM memory and volatile memory is your RAM memory. So both are important, but when your main computer is functioning, when your program is being loaded, various operations are happening, what do? We have to read some data and we also have to write some data. Okay, you have to read, write, you have to store, you have to delete. It has to happen a lot of times. Okay, so to do all this, that memory should be volatile. Okay, so your statement 1 is false. What do you think about statement 2? So to interface a 128K cross 8 RAM, we require a minimum of 25 address lines. Is this correct or wrong? Can you tell me? How many address lines do you think we need for a 128K cross 8 RAM? Oh, actually, we are supposed to solve the previous year assignment question, so I don't know why it is that much different. But yeah, it should be different actually because we shouldn't solve and give you the solution that way. Hmm. So you have 128K, right? So that is 2 raised to what into 2 raised to 10. So can you tell me 128 is 2 raised to what? Can you let me know? 2 raised to 7. Okay, thank you. So this 2 raised to 7 into 2 raised to 10. So you need 2 raised to 7 plus 10. So this 2 raised to 17. So basically you need 17 address lines. You don't need 25 address lines. That's why statement 2 also is false. What about statement 3? What do you think? Write enable time is the time to be allowed between placement of stable address and availability of stable data. Is it right or is it wrong? Yeah, it is false. That is actually read enable time. So this actually is read enable time. It should be read enable time. Then it would be true. Okay, what about SRAM using CMOS? Uses cross-coupled inverters for basic memory cell. Is it right or wrong? True or false? Okay, we are testing your memory. We are studying about memory and testing our own memories. Yeah, it is true. Okay, so which and all statements are false? 1, 2, and 3 are false. Statement 4 is true. Okay. Let us consider. Okay. Yeah, it uses two cross-coupled inverters. Yeah, inverters are there means it is plural also, so it's not an issue. So so this is question number 8. So you have a BCD input. That is, you have A3, A2, A1, A0, but it's going from 0 to 9. You have a squarer and you have two ICs. Okay, which will later on display it over here. So suppose you give 9 over here. Here in display you must get 8, 1. Suppose you give over here 4, you must get over here 1 and 6. Basically you're squaring it, right? So here this is a BCD input. This also is a BCD input only. No, it's not basically BCD input, it's just some information. And you must create that kind of circuit. Okay, so we have to look into what does IC 7447 do. Need to make it IC 7447. Hmm. So does anyone know what does IC 7447 do? Okay, okay. So yeah, so that's what I'm thinking. So you have a BCD input, then this also should be BCD information. This also should be BCD info only. And then that has, this is an interfacing board, interfacing IC. So it converts BCD to your 7 segment display. That is the objective of this IC. Okay. So now let us look into this. We'll have to draw big truth table over here. So you have A3 to A0. Okay, so you have A3, A2, A1, A0. Then you have D7, D6, D5, D4, D3, D2, D1, D0. Okay, let us say you have 0, right? So here also it should be, here also it should be 0 and 0. So that's why the information over here is 0, 0, 0, 0. So let us say this is in the integer, this integer 2 and this is integer 1. Okay. So this also should be all 0. Right now you have integer 1 here. Integer 1 means these are all 0, 0, 1. Integer, so 1 square is 1. So that means this is 1, this is 0. So the bits which you write over here will be all 0 here. And here it is 0, 0, 0, 1. Okay. Now we have 2 over here. 2 means the square of 2 is 4. So it is 4. And here integer 2 is 0. That means this will be actually, let us say, this is 0, this is 4. And this is 0, 0, 1, 0. And here you write it all as 0, right? And 4 corresponds to 0, 1, 0, 0. Okay. Now, this is 3. So square of that is 9. So this is 9. And this will be 0. So the 3 is 0, 0, 1, 1. Here it is all 0. And 9 corresponds to 1, 0, 0, 1. Now, suppose we have 4. 4 square is 16, right? That's why this should be 1, this should be 16. And then these bits are 0, 0, 1, 0, 0. And this would be 0, 0, 0, 1. And 6 would mean you have to have 0, 1, 1, 0. 4 plus 2, 6. Okay. Next, over here you will have 5. 5 means 25. So 2 and 5 over here. And so the bits would be 0, 1, 0, 1. 2 is 0, 0, 1, 0. And 5 is 0, 1, 0, 1. Okay. Next, you will have 6. 6 means 36. So 3 and 6 over here. So the bits will be 0, 1, 1, 0. 3 is 0, 0, 1, 1. And 6 is what? Again 0, 1, 1, 0. Right? Then you have 7. So for 7 corresponds to 49, 4, 9. And then the bits should be represented like as follows. 0, 0, 1, 0, 0. And 9 is what? 8 and 1. Right? This is 9. And then you have 8, which corresponds to 64. So 6 and 4 over here. And the bits are 1, 0, 0 for 8. 6 is what? 0, 1, 1, 0. And 4 is 0, 1, 0, 0. Okay. Then you have 9, which stands for, 81. And then the bits will be 1, 0, 0, 1. And 8 is like 1, 0, 0, 0. And 1 is 0, 0, 0, 1. Okay. So this is how you represent it. Okay. Now we have represented the truth table, which is quite a big one. Now let us go back to our question. They are asking us to find what is D4 and D3. Okay. We have to focus on D4 and D3. Find all the places where D4 is 1. So let us write it down. F of D4 is where and all? Here 1, here 1. So it is summation of 4 and 6. So it is summation of M 4, 6. And F of D3, what is F of D3 equal to? 4 comma 6. And f of d3, what is f of d3 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d3, what is f of d3 equal to? 4 comma 6. And f of d3, what is f of d3 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 comma 6. And f of d4 what is f of d4 equal to? 4 com This is 1 and this is 1. So 3 and 7. So it is summation of M 3 comma 7. Okay, so this is how this circuit is written. This is how it is made. All right, so that is how you have to program the ROM and everything you have to do. So this is just an example says that it how you apply this ROM circuit for some particular application, IC, everything, you're able to understand it through these circuits. Okay, through these questions. So let's go to question number 9. Question 9. So flash memory is faster than EEPROM as data writing is in block, example 512 bytes instead of 1 byte at a time. Is it true or false? What do you think? Yeah, it is true. Very good. Okay, flash. And you also told the answer in a flash. Good. Now let us look into this. Then question. So which of these statements are true? Which of these statements are false? So in 1T DRAM cell, reading can be destructive due to high parasitic line capacitance. Is it true or false? Okay. So yeah, it is reading is destructive due to high parasitic line capacitance. This is true. Okay. 3T DRAM uses a separate capacitor for data storage, whereas 1T DRAM uses parasitic capacitance of MOSFET. This is false because even 3T DRAM uses the parasitic capacitance of the gate of the MOSFET. Okay, the gate of a MOSFET has a very high capacitance, and there you can store information. That is the way, like in a normal SRAM cell, static RAM cell, you need 6 transistors. Okay, to store 1 bit of information. But when you come to 3T DRAM cell, you need only 3 transistors to store 1 bit of information. So there is some trade-off will be there. By now you would have realized by when you have looked into various circuits over this overall long 12-week course, right? If you want to gain something, you have to lose something. There is a cost. So the 3T DRAM cell also uses the parasitic capacitance of a MOSFET, the gate capacitance of a MOSFET to store charge. And because of that, what you have to do is you have to periodically refresh that charge because what happens, that charge will slowly discharge. Okay, it will slowly discharge. And because that charge is slowly discharging, you can't just leave it infinitely. You just cannot leave it like that and expect that information to be stored. So you have to keep on, refreshing that information over there. Okay, so that is one thing regarding the DRAM cell. Now, both capacitances of a 40 DRAM cell charges when refresh signal is made active. Is this true or false? This is false. Very good. So what happens is, yeah, they are parasitic capacitances. That's correct. And but if you know, like in these memory cells, which you would have noticed, there's a data line and there's a data bar line. So the data line is 1, the data bar line is 0. So one capacitance is high, another capacitance is low. So that means the capacitance which is high, that needs to be charged, right? So that's why only one of the capacitances charges when refresh signal is made active. Okay. So this is false. Then Address range of a memory cell can be increased by using additional decoder and chip select input of a memory block. Yeah, this is true. When we use additional decoders, everything, we can increase the line. Yes. So this is true. Okay, so what do you get? We got get the first and fourth. They are the true options. Okay, let us now look at this circuit. It's a very interesting one because this is regarding a PLA. Hmm, how do I draw it? Me snip it. Okay, so you would have studied, you would have learned in the videos you would have seen there's the ROM. Basically, what is ROM? Means you have a decoder. Decoder is made up of AND gates. Okay, and this is a fixed logic. This is followed by OR gates, which is programmed or burnt. You have certain fuses, they are burnt, they are like too much current is sent and then that fuse melts, and then that connection is made strong, like it is fixed, right? So what is there? The OR gates are programmable, but the AND gates are fixed. Okay. Okay, Umkar Prasad, I don't exactly know what are like the main important topics for you to score very good marks. You can have like K maps is something which you should know. You have AND gate, you have like various basic logic gates are there, which is simple. High scoring probability, there's no such subject concept of weightage over here. So I don't know what will be the scoring pattern, what will be the weightage for questions, everything. One thing is known that you have to go through the assignment questions, like all the assignments 1 to 12, kindly solve it. Try to understand. I think the solutions also are being released, which is very good for you guys. So you access those solutions, understand why each question, what is the solution to it, how the solutions were given, and then you prepare. So there is no such concept of weightage, everything. So I know, like in our engineering thing, each topic has some particular weightage, and if you study this lesson or this topic, you can pass. You have to just study 2 3 topics and you can pass. That is good for BTech engineering, but for this NPTEL course, I don't think such an option is available. I don't know. Yeah. Yeah. But I'll recommend go through the assignments, solve the assignments by yourself. Then whatever problems you are stuck, you go to the assignment solutions. See it even for the questions which you have solved on your own. You see whether the assignment solution provides you an easier, smaller, shorter method to solve your questions, because it's a question of time when you're doing these exams, right? And here the steps are not that important. The importance is you have to get the correct answer. Here you don't have marks for steps, right? So that's why you see what are the ways you can refer to that assignment solution. It would be very useful for you. And first, try solving the assignments on your own. Don't go to the solution first. Think, spend some time. It will be hard. I know it will be hard. And you try to understand why the solution has come, what is the main topic, everything, and go. Also, when is the exam for your digital electronic circuits? When is the exam date? Has it been, you would have gotten it, right? Okay, Friday. Oh, you have only 3 days. Okay, all the best. Yeah, it is quite difficult to study within 3 days, but yeah, you can try. And mm, so your exam centers, everything is fixed, right? Yeah. Okay, okay, fine, fine. Okay, so I guess all I can do is tell you all the best. If you want, there are certain these whatever sessions I've taken, the recordings are also there, so you can refer to it. There I have certain solved certain previous year assignment questions. I have solved it, but most important is you have to try solving questions on your own, alone, on your own. That's where you, because in the exam you are going to do, you're going to attempt the questions on your own alone, right? So start, try to get the practice of that. Hmm. Okay. So let us go to this PLA circuit based question. Okay. So we have to find what will be the expression for F1 and F2. So PLA is programmable logic array. There is, okay, I was talking about ROM, where your decoder is AND gate fixed and this is OR gates. Or then you have what is known as PAL, okay, where AND gates are flexible, but you have some fixed OR gate configuration along with some feedback, everything is there. Then finally is your PLA, where you have AND gate is flexible and your OR gates also are flexible, along with some few feedbacks are there. So these are the three different types of memories are also there. So now you will have A, so this will be your A bar. Then you will also have B, will have B and B bar. C will also have C and C bar. This is there. This is known. So yeah, so it's also provided here. Here you have A bar, A, B bar, B, C, and C bar. Now this is your these are your AND gates. Where if you will zoom in, right? Let me zoom in over here. What do you see? You see one cross here, one cross here. That means they are inputs. They are inputs to this AND gate number one, right? Then, so let us write what is your AND one. So your AND one basically is equal to A bar and C bar. Okay, now let us look at AND two. This is here, here, and here. So AND two is equal to A and B and C. Then let us look at AND three, which is C bar and B bar, right? So you have AND 3, which is B bar and C bar. Then you have AND 4, which is A and C. So you have AND 4, which is A and C. Okay, good. Now, so you have got your, you have got your AND 1, you have got your AND 2. These are certain expressions which you have got, right? You have got those expressions here. Now, you these are OR gates and you will find out. So it is connected here, here, and here. So this is your OR one. Okay, this is your OR one. So what is your OR one? Your OR one is actually equal to AND one plus or AND two or AND three, which actually corresponds to what? A bar and C bar, or A and B and C, or B bar and C bar. Okay, good. Now we have to find what is our OR 2. OR 2 is AND 2 or AND 4. So OR 2 is AND 2 or AND 4 which is equal to A and B and C, or A and C. Okay. So now we have come till here. Very good. Now you have to find F1. So now you can see F1 is XOR of 0 and all. So F1 is what? 0 XOR with or 1. 0 XOR with anything is actually equal to or 1. So your F1 is equal to or 1 is equal to A bar and C bar, or A and B and C, or B bar and C bar. Next, you have F2 is basically what? F2 is 1 XOR with or 2, right? 1 XOR with or 2 will actually be or 2 bar. So your F2, which is equal to or 2 bar, which is equal to A and B and C, or A and C bar of that. Okay, right. So we have got the expressions of F1 and F2. Now, how is the solution given? If you see the solution, it is pi m. That is, it is product of sum. It is not sum of products, it is product of sum. So this is in terms of max terms and not in terms of min terms. Okay, so we have to therefore accordingly now, analyze and simplify your F1 and F2's expressions. Okay, so let us say you have your F1, right? F1 is equal to A bar and C bar, or A and B and C, or B bar and C bar, right? So that is actually, how do we write it is, we write it as A bar and B, or B bar and C bar, plus A and B and C, plus A or A bar and B bar and C bar. So F1 is actually equal to A bar and B and C bar, plus A bar and B bar and C bar, or A and ABC, or A B bar and C bar, or A bar and B bar and C bar. Okay, these two are the same, we can merge it. So F1 basically is equal to A bar and B and C bar, or A bar and B bar and C bar, or A B C, or A B bar and C bar. So now let us first write it in terms of min terms. So it is summation of m. Okay. Now this is what? 0. All are 0. Then what is this? So it is 0. Then A bar and B and C bar is actually 2, right? Then this is what? 4. And this is what? 7. So F1 is summation of M0, 2, 4, 7. So F1 actually is equal to product of the other terms, that is 1, 3, 5, and 6. So we got F1. Okay, we wrote it in terms of min terms, and max terms is just, the whatever terms are there in the min terms, the rest of the terms will be the max terms. So it is very simple for us to convert. Okay. Now we'll focus on OR2, which is actually F2 is OR2 bar. So let us start with OR2 is equal to A and B and C, or A and C. So it is A and B and C, or A and C. Okay. So this also we can expand it. A, C, B, or B bar, right? It is ABC plus ABC plus AB bar C. So it is what? ABC or AB bar and C. It is summation of M. What summation of M? Uh, A, B bar and C. It is 4 plus 1, that is 5. And this is all are high, so it is 7. Okay, so this is 7. So what we got? We got our OR 2 is summation of M 5 comma 7. Now our F2 is OR 2 bar. It is bar or summation of M 5 comma 7. So it is basically the product of 5 comma 7. Just a complement. Okay. Yeah. So any queries in this part? Okay, very good. So there is this question which we have not looked into. We will just check it now once. So they're saying a RAM chip has a capacity of 2K cross 8, and you have 2 cross 4 decoders with enable line needed to construct a 128K cross 16 RAM from 2K cross 8 RAM. Okay. So basically, you have a RAM here, which is basically D7 to D0. It has 8 bits, and 2K means it has 11 bits address line. So basically, it is what? A10 to A0. That is equal to 2K, right? So this represents a 2K cross 8 memory. Now, you also have what is known as a 2 to 4 decoder. So you have a 2 to 4 decoder with enable. With enable. So you have an enable pin. You have your control 0, control 1. Then you have D0, D1. Let's not use D0, D1. Let us see your term 1, term 0, term 1, term 2, or term 3, right? These are the possibilities. So what do you have in this is you have C0, C1 enable, T0, T1, T2, T3. What may be C0, C1? If enable is 0, all of this are 0. Now, but if enable is 1, right? If this is 0, 0, means you must select T0. T0 will be 1, sorry. T0 will be 1. Rest all are 0, 0. If this is 0, 1. T1 is 1. Rest all are 0, 0. If it is 1, 0 means T2 is 1. Rest all are 0, 0. If it is 1, 1 means T3 is 1. Rest all are 0, 0. Okay, so this is a 2 to 4 decoder with enable, right? Now, They are saying you need to generate a 128 kilobytes of memory into 16 RAM. Okay, you need to make such a big RAM. So they're asking how many 2 to 4 decoders with enable line is needed for such a complex task. How do you do it? Any thoughts? How do we tackle this question? Okay. All right. So let us think. So you basically need an overall structure which will have D15, D14 all the way till D1 and D0. So this is your memory which you want to have externally, like from big overall system perspective, you see like this, right? And you will have here, you will have A15. Okay, 128K, I forgot. 128K means how many bits? 128K. So that is 128 is 2 raised to how much? Can you tell me? 128 is 2 raised to what? Yeah, 2 raised to 7. Correct. So it is 2 raised to 7 into 2 raised to 10. So that means you need 2 raised to 17. So that means this will start, and this line will basically start from 17 minus 1. So A16, A15, all the way till A1, A0. Okay, this is the address line. Okay, and this is the data line. So, but we have this block. We have the block for D7 to D0, but we want to convert it to D15 to D0. So what do? We store 2K cross 8 here, 2K cross 8 here, right? And here you have D15 all the way to D8, and here you have D7 all the way to D0. So this is one block. Okay, this is one block. Now, over here, what do you have? You have some lines, right? It is 2K cross 8, so you have actually A10 to A0. This also is A10 to A0, right? So basically, this is the address line of A10 to A0. This also gets connected over here. Hmm. But you want basically what? So this converts into what? You have a 2K cross 16 memory. So if you look at this externally, this is a 2K cross 16 memory. So now you need 128K cross 16. So you need to have, So this is like basically this is your one block now. You need to add overall, you need to have 128K divided by 2K. That corresponds to 64 such blocks. You need to have 64 such blocks, right? You will have 64 such blocks. So if you have 64 such blocks, then you cannot only use A10 to A0. So that is why you need, so let us say this is your block 1. Block 1. Then you will have another block 2. So this is what 2K cross 8, 2K cross 16 now. This is also 2K cross 16 now. You'll have another block 3, which is another 2K cross 16, and so on. So now you are sending the same A10 to A0. That's going here. That's also going here. That's also going here. So if I give A10 to A0 something, it will all get enabled for some particular address, one particular type of address. But which one? And this will have, your D15 to D0. This also is connected here. This also is connected here. So all of them will give some value, right? All of them will give some value, but you need to enable one particular block. You need to make sure that one block is enabled or a next block is enabled, or you need to have an overall structure where it will be one block only is enabled at a time. And then inside that block, you have your overall 2K cross 8, another 2K cross 8, and those are enabled accordingly. So you basically you have a memory, you have a big structure, inside you have a smaller structure. Inside that smaller structure also you have further substructures and so on. So it's I understand it's getting a bit complicated for you to understand, but basically we have 64 blocks and we need to access them, right? And what do we have for that? We have our now remaining A16 to A11. So you need a 64 to 6. No, you need a 6 to 64 decoder. You need to build a 6 to 64 decoder. And what do you have? You have a 2 to 4 decoder with enable. Okay, you have to use 2 to 4 decoder with enable, and you have to make a 6 to 64 decoder, right? So this can be something which you can look into, although it is like very, very complicated. So it gets very difficult to understand. But let us say you have this, right? You have another block here like this. This is a 2 to 4 decoder. This is another 2 to 4 decoder. This is your enable pin. This is your enable pin here. So this, let us say, this is your A0, A1. This is your A0, A1. And this will have a NOT gate here. This is your A2. And this is your A2. So if A2 is 0, that means this memory is enabled. And if A2 is 1, that means this memory is enabled. Okay. And from that, what do you have? You have your D0, D1, D2, D3. That is also connected like this. Here, over here, over here, over here. Here also it is D0, D1, D2, D3. So whichever is enabled, and based on your A0, A1, or whichever A0, A1 is set, you will get that data. So that data will be accessed. Okay. So that is how you make one larger memory from small sub blocks of memory, and small enabled decoders, etc. can be used. Okay. Hmm. So I'll leave you with this. You can access these, you can refer to these notes. I will upload these notes as well. I will also upload this uh, recording session for you to access it, right? Yeah. So if you have any doubts, any queries, anything you want me to explain, you can let me know so that you can prepare well for your exam also. I've already shared various tips which I hope will be useful for you. I hope these sessions also have been useful for you. If you have any feedback, you can let me know. And yeah, you can also introduce yourself. You can let me know from where you are, what you're currently doing, which college or which stream you're in. You can text me. You don't need to unmute and tell me. You can let me know. So I have always been telling you that I'm a PhD student at IIT Kharagpur. So you know me. I don't know you, so you can let me know that. Okay, which topics I think to be important. Uh, First of all, I have to remember the topics. That is something. So just hold on 1 minute. Okay, 1 minute. So this is the course outline. Okay, I think it's not shared. Let me share. Okay. So there are various things taught in the course. Week one was the introduction, switching and logic operations, diode and transistor as a switch. What is noise margin? What is fan out? What is TTL, Schottky, everything. Personally, I feel that week one is sort of a little bit difficult. Okay, week one is difficult, slightly. Okay, let us say week one is slightly difficult. Week two is very important. This is like the basics. You really need to know it well. What are the logic gates? What is positive and negative logic? Boolean algebra, because those are things which you will be using continuously, consistently. K map, don't care. It's very important and very easy for you to know also. Okay. K maps are really important. You really need to know how to use K maps. You really need to know how to simplify Boolean expressions. There was also something of 5 variable K-map also was taught by sir. Okay, that is good. Then next, you have minimization using entered variable map, minimization using QM algorithm. Those are kinda you can minimize. See, basically, you just have to minimize. You can also use Boolean algebra to minimize, right? There's static 0 and static 1 hazard. Those are interesting, like the static 0, static 1, how to overcome that. Those are interesting, but this is like something you can try. Okay, week 3, something, these entered variable map, QM algorithm, those are a little bit, QM algorithm is very difficult. You just try to understand what it does and keep it to that. You don't need to, do a QM algorithm. So I don't think it's kind of difficult. So you can try to avoid that. The multiplexer, demultiplexer, decoder, BCD to 7 segment decoder driver, encoder, priority encoder, parity generator, and checker, those are important. Hmm. Achha. Okay. So, I think basically I can, what should I do? Usually, what do we have? We have another summary session we conduct, but this time there is possibility is not there. I don't need to do it, so it will not be conducted. Mm, Like multiplexer, demultiplexer is basically you're having, okay, summarizing each week, right? So let's start at week 4 now. We have discussed. So week 4 is basically your when you have to manipulate multiple signals. What do you have? You have this mux, right? Your select line S1, S0. This is your what? Data 0, data 1, data 2, data 3, and this is your Y, right? So if S1, S0 are 0, 0, then what will be? Your Y will be D0. If it is 1, 0, 0, 1, accordingly. So this is basically your mux. Then you have a demux. Demux is just the opposite, right? Again, you have S1, 0, you have an input Y, but where it will go? It will go to D0 or D1 or D2 or D3. This is known as your demux, right? Then what you do is demux, you can convert it to a decoder. Instead, you take your S1, S0 over here, right? And this Y, you put it equal to 1. And this becomes equal to your decoder. Okay, similarly, you'll have something for encoder and everything. You can check that. Then you have a BCD to 7 segment display decoder driver, right? So you have your binary coded decimal that is from 0 to 9, right? But you need 4 bits for that. And when you need 4 bits for this BCD 0 to 9, what do you have to do? You have to convert it into the 7 segment display, right? Into these 7 segments. So for here, you should be very well versed with the truth table. So let us say this segment A, B, C, D, E, F, G. So for what number, which one has to be high? So that is your BCD to 7 segment decoder. This is week 4. Week 5 is good. Your ones complement, twos complement, those are important. Okay. Codes, code converter, adder, subtractor, BCD arithmetic, those also are good, right? So you suppose you have your number 010. What is its ones complement is 101. And what is its twos complement? This will be your 011. So this is your ones complement of it. And this is your twos complement of it. Okay. Signed binary, octal, hexadecimal numbers, those also are simple for you to represent it. Then you have various types of adder circuits. You have magnitude comparator, ALU, error detecting. What I'd like you to do in those cases is you try to identify what circuit is there. And once you identify the circuit, you will know what that circuit actually does. Okay. You try to know what that circuit actually does. See, there are so many circuits you have seen throughout this course, right? But what you should know is you should identify what the circuit does. If you understand it does an adder circuit job, you don't need to do, the binary addition or the threes complement addition or those ways. You don't need to try that. You don't need to do BCD arithmetic addition carefully, seeing that it'll take your time. You don't need to do that in the exam. You convert that BCD number into the normal integer number and then you just add off. That will get you your job done. Okay. ALUs like an arithmetic logic unit. Error detecting and correction codes, those are there. It will take time. It's not something you can quickly grasp and remember. Okay. What I want you to do, you have just 3 days. Do topics which are easy, simple, which you have worked with, and which are come fast. Okay, which can be good. So week 7 is very important. Latches and flip flops. What is the truth table of SR flip flop, D flip flop, JK flip flop? How from SR flip flop you convert it to D flip flop? From D flip flop, how you convert to JK flip flop? What is a toggle flip flop? What do you mean by level triggered, edge triggered? Master slave also is there, and various representations of flip flop is also good. Okay, because this is your sequential logic. These are your sequential circuits. Till week 1 to week 6, they are all combinational circuits. But now in week 7 onwards, we are looking at sequential circuits. Okay. Hmm. Then, how do you use the circuits and how do you using flip flops? How do you make a sequential circuit using flip flops? Then what is a register? Register is what it is does. It stores data. Yet register is using for stores data, storing information. So basically, a memory cells also is basically some form of register. Then what type of you have a universal shift register. Shift register basically is what? Register means you have, let us say this is a 4-bit register. It has some data. Let us say it has data A0, A1, A2, A3. Shift register means this data can be shifted to the left, it could be shifted to the right, it could be, cycled back. All that is the concept of the shift register. Hmm. Yeah. Then you have this linear feedback shift register also is there. Also, there are various counters. If the shift register is configured, when you just take it like this shift register is just configured in one feedback, you get a ring counter. If you add a NOT gate, it becomes a Johnson counter and so on. Okay, you just go through those circuits, try to realize that. Then you have an up-down counter that is simple to understand. A counter which is going up or a counter which is going down, or you have an up and down counter also is there. Then asynchronous counters means it is ripple. That is the output of one flip flop will go to the next flip flop and next flip flop and so on. So there's a delay. But synchronous counters means all the flip flops are synchronized. They change their state at one particular instant. Okay. Then how do you design a counter using flip flops? Those also is a good and easy question. So that was week 9. So counters are something which don't have much of an external input. But then your sequential circuits have certain inputs. So then there is a milli model, there's a Moore model. Milli model is faster than Moore model. It has less delay. Moore model has more delay. But milli model is like it is dependent on your input changes can affect your milli model, but Moore model is less affected by that. For that, you also have a state transition diagram. You have the excitation table you have to use. And you can do various reduction techniques as well are there. Week 11 is very practical. Once you go to your projects, everything, you need to know what is a DAC. This is a very important, easy, I think, for you guys to understand. DAC is important. ADC is important. What are the various types of ADCs are there? What is the range? What is the quantization, accuracy, and resolution? This is important. This I feel is something you should focus on. Then week 12 here, it is mainly theory. It is mainly theory, and you should, the trick is you must identify the circuit. Now I'm just giving you a brief thing, but in the exam, you will not know that which circuit, which question is coming from which week. you should be able to, identify the circuit. Once you identify the circuit, you'll understand what it works as. And once you know how it works as, accordingly, you can try to align the way you look at that question in that fashion. And once you do that, it becomes easier for you to, solve the question. Okay. Yeah. Okay. So I hope I've given you a very brief and a very quick recap of the course, which is not at all comprehensive. It's just a brief skim through. So I hope you'll be able to do it well. And do let me know how the exam goes as well. All the best. Yeah. And yeah, so I'll be uploading this video on YouTube soon. You can access this as well, and you can go through your various assignment questions. Please go through the assignment questions, go through the assignment solutions very well, rigorously, properly solve it. Take some time and spend some time and do it, and go forward. Okay. Okay. Thank you. Okay, so I'll end the session. Thank you for joining.